We challenge the view that aging is something we have to accept. We challenge the view that aging is untreatable. We challenge the view that aging is different from disease. But we're showing now that it's really easy to reverse it once you understand why it occurs.
Aging is a part of everyday life. It's guaranteed to happen to everyone. Eventually, we all get old, develop diseases, slow down, and eventually die of old age. We all understand it. But what if we actually don't understand it? And what if things didn't have to be this way? What if we could slow down the clock and even turn it back? Well, researchers are developing ways to unlock the tools within our own body to help us do exactly that. In this video, we'll take a look at something a little different: health regeneration. These are two mice. One looks young and healthy, the other decrepit and old. But these mice were actually born on the same day. In fact, they're twins. Dr. Sinclair at Harvard Medical School led a team of researchers in this experiment. The goal was altering the epigenome in the DNA in one of these mice. So what is an epigenome? In short, it's responsible for coiling up and turning on and off parts of a DNA string as required. Depending on the parts of the DNA that is turned on and off means the difference between creating a skin cell versus a nerve cell. Our DNA is effectively the code which tells our cells what to be. As we age, researchers believe that our DNA epigenomes unravel, and other parts that weren't meant to be coiled become so. Effectively, our bodies begin to create the wrong cells in the wrong places. This deterioration of epigenetic information is what Dr. Sinclair's team accelerated in one of the mice. Therefore, one mouse literally aged faster than its twin. Aging is in fact something that our DNA tracks very accurately and quantitatively. This is how it's done. DNA is made up of 4 different components called nucleobases. They are A, C, T, and G, and they're paired together to make the famous double helix structure. Over the course of our lifetime, methyl groups, which are just a carbon with 3 hydrogens, begin to attach to the C components of our DNA. By measuring your DNA through a blood sample or a mouth swab, scientists, with the help of AI, can tell exactly how old you are based on how many methyl groups you have. This is called the Horvath clock. It's extremely accurate and can even predict when you'll die. This is a recent discovery, and it's not just an accurate measure of biological age. Researchers believe that the clock itself is part of the aging mechanism. Hence, physically being able to dial back the hands of the clock could mean becoming physically younger. However, this appears to be one of many interconnected mechanisms that control aging. The analogy used by Dr. Sinclair is that our epigenetic information is lost over our lifetime, much like a CD gets scratched over time and begins to glitch. The old theory was that our DNA information gets lost over time as we succumb to entropy. In the old theory, the damage comes through free radicals, oxidization, DNA mutations, and damage. Dr. Sinclair believes that we should throw that theory out. It's not the loss of DNA itself, but the on and off switches on our DNA. So, is there a way to polish our genetic CD and get the information back? And if we push the reset button, how many times can we do it? Is there a limit? Well, there's some promising research being carried out. The doctor and his team were much more interested in reversing the processes of aging rather than inducing it. What would come after the initial mouse experiment could prove to be a revolutionary step. Again, these are 2 mice on a treadmill. Both are 20 months old, the equivalent of approximately 70 human years. But one has been treated with the chemical compound known as NMN. If you guessed the mouse on the right, you'd be correct. treated mice ran on average 430 meters compared to the untreated control group, which ran 240 meters. As the experiments progressed, some peculiar things began to happen.
The mice that we treated with NMN, they just ran and ran and ran. They actually broke the little treadmill in my lab because they ran so far. And I get a text from the researcher, hey, the machine broke. And I said, check the software. And it turns out the software was written to stop at 3 kilometers because no mouse had run that far before.
That's long.
And those are old mice. Don't forget, these are mice that are the equivalent of a 65-year-old human. They ran and ran and ran. They didn't get lactate buildup as much. They just didn't feel tired.
These chemical compounds all help increase something called NAD levels in the body. Dr. Sinclair's research is trying to link NAD with aging. NAD is central to the metabolic system, helping carry electrons between reactions within all living cells. Sinclair and his team are testing NAD boosting drugs on the elderly and hoping to get FDA approval for use in diseases in the next 3 years. Other factors apart from specific drugs that boost NAD levels are natural things such as exercise, a good diet, and even fasting, which Dr. Sinclair practices himself. So to be clear, living a healthy lifestyle naturally boosts your NAD levels. But it's the drug component of increasing NAD levels that is potentially a game changer. However, there's understandably some controversy around so-called fountain of youth pills. Some saying current research doesn't back up the claims, others using anecdotal evidence to the contrary. While there is evidence to show that the use of compounds such as M&M increase NAD levels in the body, there still isn't concrete evidence that NAD levels increase longevity, and human trials are still ongoing. There is, however, a decline of NAD levels with age, and this was the spark that turned researchers to focus on NAD as a proponent of aging. With time, we will see if the trials on mice can be carried over to humans. But this all doesn't end there. Another interesting discovery, which may be fundamental to getting humans to be able to regenerate their bodies, is something called the Yamanaka Factors. These are named after the Nobel Prize winner, Dr. Yamanaka, who used these factors to convert human adult cells into stem cells, effectively a blank canvas to be used anywhere in the body. Dr. Sinclair's team attached some of the Yamanaka factors to a benign virus and then injected it into 2 mice. The researchers pinched an optical nerve in the eye of both mice, effectively crushing it. Now young cells will regenerate and heal themselves, while old cells will struggle. Some species even have the ability to grow entirely new limbs. What if there was a way to find the part of our epigenome responsible for regrowing damaged or lost parts of our bodies, and then turn it on? More on this later. Back to the experiment. The effect of the Yamanaka factor virus can be seen. The top image shows no treatment, and the cells don't regenerate and fix themselves. The bottom image shows a treated mouse. The cells in this mouse actually begin to grow back towards the eye, and within 16 weeks, they repair entirely. Could this eventually be a key to treating degenerative diseases? For example, poor vision due to age. Perhaps this technology could repair the eyesight of the elderly, and maybe even injuries like spinal injuries. It's interesting to think about. Dr. Sinclair explains that at least in mice, researchers know that they can positively improve vision. The cells that were old begin to wake up. They begin to remember that they are a photoreceptor cell and not a half skin cell. They are measurably younger. Parts of their genome that are meant to be on are turned on, and the parts that are meant to be off are coiled up. And even if this is true just for mice, it really is amazing.
We find that with our reprogramming, we can make the nerves be just like a newborn baby. They grow back. And then we also tested on glaucoma, pressure in the eye. We increase pressure in the mouse's eye and they lose largely their eyesight, and we can recover that. And then we also test old mice that don't see very well, and we also seem to improve their eyesight almost back to normal. So what I don't think we'll be going to nursing homes anytime soon, but what we are doing is running a clinical trial on this. And so we're looking to do that in early 2020.
And the clinical trial will be on people with glaucoma or various eye issues?
The plan is glaucoma first, but it could work for
other damaged retinas as well. Even broken spinal cords we're thinking of trying.
The ability to turn on or off specific parts of the genome is a very interesting proposition. We could turn off parts of our genes, which may cause genetic diseases. So in conclusion, Dr. Sinclair's work is on the cutting edge of research into the aging process. While he doesn't claim to have found the fountain of youth, his research is very promising and could lead to some very inspirational outcomes. At the very least, we could help improve health for those later in life. This would give people a better quality of life in their final decades. But interestingly, it could also save trillions of dollars in the long run, as there would be much less of a burden on our healthcare systems. But at best, we could unravel the secrets to our own bodies, discovering parts in our DNA we never knew existed. We could help reverse diseases that are incurable today and live longer and healthier too. This field is a rapidly evolving one, and right now is still in the research stage. It will probably be decades before this technology, if even possible, will become available for widespread use. Regardless, it's still interesting to see how such new fields of research are emerging. Of course, there should be some caution in how we proceed when it comes to modifying genetics. But for increasing NAD levels at least, there doesn't seem to be much of a downside, and that's probably because NAD is a natural chemical that comes from a healthy diet and exercise. If we do in fact get there, this could turn out to be one of the most pivotal things the human race has ever done. I'll be watching this space.
With every action, we assume there's some negative consequence or potentially negative consequence, right?
We always assume that, but it's not always right. So with the molecules that we've been testing for years now, like NMN, we haven't seen any downside, just longer endurance and protection. So there isn't always a downside to these things. In fact, if you just think NMN is replacing a molecule that we lose over time as we get older, it's just becoming, it's a fairly natural process. No downside exercising and dieting either.